Good evening, my students. Welcome to the session number 3 for 15 CV33 Fluid Mechanics Module 1. The module covers fluid and their properties, fluid pressure and its measurements. In the previous two classes, we have covered the theory portion of the fluid and their properties. Today, we will take the problems, but before jumping to the problem, I would like to revise the objective as well as the summary of the formulae which we are going to use today. The outcome is the student will learn the fundamental properties of fluids and its applications, and student will learn the hydrostatic law and application to practical problems solving. So, these are the two objectives for the module 1. Let us summarize what we have discussed in the first two sessions of our lecture. We have described various fluid properties starting from mass density, which is rho f. The formula is mass per unit volume, mass is in kg and volume is in meter cube. The formula is m by v. Opposite of this, that is 1 by density, is called specific volume. I repeat, 1 by density is called specific volume. Obviously, the units will be meter cube per kg, opposite of kg per meter cube. We have a very important property called specific weight. Specific weight is nothing but the weight per unit volume. It means it is equal to density of the fluid into acceleration due to gravity, and the units are Newton per meter cube. Is it okay? So, the specific weight represents weight per unit volume. We have a wonderful number called specific gravity, which is nothing but the ratio of density of the fluid to the density of the standard liquid. Repeat, the specific gravity is a number which is nothing but the ratio of the density of the fluid on the top, and the bottom we have a standard fluid, normally water, and the density of water at is 1000 kg per meter cube. We have one more definition called viscosity. Viscosity is nothing but the resistance to flow. Viscosity is nothing but resistance to flow. It is defined by Newton's law of viscosity, that is tau is equal to shear force divided by area is equal to dynamic viscosity into velocity gradient, that is du by dy. Mind it well, mu is the dynamic viscosity. There is one more term called kinematic viscosity. You can see in the fourth bullet, the kinematic viscosity is defined as the ratio of dynamic viscosity to density. Repeat, the kinematic viscosity is defined as the ratio of dynamic viscosity to the density of the fluid. The unit is meter square per second. Normally SI unit is meter square per second. The CGS unit is strokes, which is centimeter square per second, and we have one more centi stroke, which is 1/100th of a second strokes. Now, apart from this, what we have discussed yesterday, you remember I have talked about cohesion and adhesion. In that, you will find very interesting phenomena called capillary rise. The capillary rise is the rise or fall of a liquid column. It may be a water, it will rise. It is a mercury, it will drop. Yesterday we have seen those things. The formula is to calculate the capillary rise or the drop. The formula is 4 sigma cos theta divided by gamma of the liquid, that is specific weight, into diameter of the tube. Hence, H can be calculated based on surface tension of the liquid, angle of contact, specific weight and diameter of the tube. Higher the diameter, lesser will be the rise. Smaller the diameter, higher will be the rise. Yesterday, remember, we have shown you the video also on the same, but mind it well, the cos theta, which is angle of contact, which is normally almost 0 for water air or around 10 degree, it may be given in numerical, or if it is a mercury, the theta value is 128 degree or 134 degree, which is nothing but a negative value. So, capillary rise for water will be positive and capillary rise for mercury, because cos 90 plus theta is minus sin theta. So, there will be a mercury drop, correct. Now, we have defined one more term called bulk modulus. Normally, in the fluid category, we have two, one is the liquid and other is gas, and liquid is practically considered as incompressible. Liquid is considered practically as incompressible. Gases are compressed. Bulk modulus is nothing but the ratio of change in pressure divided by volumetric strain. Change in pressure divided by volumetric strain. The negative sign is coming because of the opposite nature. What is the meaning of that? If I increase the pressure, volume will decrease. If I release the pressure, volume will increase. That is the meaning that K value is there. We have talked about one more important thing, that is called excess pressure. The last formula, you can see the soap bubble, if it is there, the formula stands, the excess pressure delta P is given by 4 times surface tension divided by radius of the soap bubble. I repeat, the excess pressure in a soap bubble delta P is given by the formula 4 into surface tension divided by radius of the bubble. But if it is a water jet, it is delta P is equal to sigma by R. So, these are the characteristics we have discussed so far. So, my dear friends, all of you should be ready with your calculator and try to solve the problem one by one. Let us start first problem on system of units. The question number 1 is on system of units. Express the following in SI units. I think I already told you we are having the international system of units, and any quantity is given in any other dimension or other units need to be converted to SI. SI unit we are going to follow. Is it okay? So, in the first question, the first value is mass 50.968 kg to weight. He is asking you, mass is given, I need to convert it to weight. Second one is 25 liters of any, maybe milk, maybe water, whatever it is. Number 3, a diameter is given or a length is given 200 mm, and fourth is a 30 degree centigrade to Kelvin. Now, we will start with the first one. Take out your calculator. You know very well the formula weight is equal to mass into G. Weight is equal to mass into G. What exactly it means? The weight of any fluid is equal to mass of the fluid, which the value is given as 50.968, which I am underlining with the cursor, into G. I think acceleration due to gravity, normally I know it changes from place to place here and there, small variation, but standard value will take 9.81. In some of the numericals they take even 10, so do not get confused. You take mass 50.968 kg into 9.81 meter per second square, that will give you the weight of that particular fluid or liquid as 500 newtons. Is it okay? I hope you might have already calculated by your calculator. Let us take the second one. The second one on system of units, we want to convert this volume, that is 25 liters of can is there, 25 liters is there. I want to convert this to meter cube. Okay. So, what I will do, 25 liter divided by 1000, I will divide it by 1000, right. So, the answer is 0.025. So, mind it well, if I am talking about liter, we need to convert to SI system by dividing it by 1000 in the numericals. Is it okay? It seems to be okay. Next, the third one is very simple. It's the diameter of a pipe or a length is given as 200 mm or 20 centimeter. We need to convert into meter cube. The answer is simple. Mm to meter we divide by 1000. What is that? 200 mm is given. We need to convert to SI unit in meters. I am dividing it by 1000. 200 by 1000. The answer is 0.2. Is it okay? Have you done it? Now let us see the last part of it. Last part is temperature. Temperature is 30 degrees centigrade, which is normally in the atmosphere. For example, if AC is there 27, 24 around, outside if you go it's around 30. So we need to convert it to degree Kelvin. You add 273 to this, you get 303. So we need to add 273 as a constant to the temperature to get into the Kelvin. So this question, which is a very simple question, it gives an idea how the weight is getting from the mass by multiplying by g, how the volume is converted to meter cube by dividing by 1000, and how the length is converted to meters, means 200 mm to 0.2 divided by 1000, and temperature to degree Kelvin by adding 273. Hopefully this small question will make you aware that this kind of conversions we are going to do in further problems. Is it okay? Let us take one more problem, again in the system of units only, but this time we are going to touch the dimensions. I repeat, the question number 2 is on system of units. We are going to verify the dimensions in MLT system. You remember in the first class I told there is a basic system, primary system, mass in kg, length in meter, and time in seconds. Any quantity which is derived based on this is called secondary quantity, and these are the primary quantities. Let us read the question. Verify the dimensions in MLT system of the following quantities which appear in number 1 acceleration, number 2 moment of inertia, which is area moment of inertia, number 3 work done, and fourth one is the strain. These are the very common quantities coming in our engineering sciences. Acceleration, as you know very well, the dimension is meter per second square, correct? Acceleration, you can take acceleration to do gravity, say 9.81 meter per second square. M stands for length, S stands for T. Repeat, M stands for meter stands for length, and S stands for time, and you can see there is a second square, so I put T square. So what is dimension, my dear students? It is LT minus 2. Then you may be thinking about velocity. Velocity is meters per second, correct? So it will be L by T, LT minus 1. Like that we need to derive the basic dimensions of these important quantities. Let us take the second one. Moment of inertia, you might have studied in first year. Moment of inertia of an area. It could be mass moment of inertia, it could be weight moment of inertia, but I am talking about moment of inertia of an area. It will be equal to area into distance square. You may be thinking why distance square has come, because moment of inertia of any quantity is the second moment of the area. Second moment means distance square into area. If I say mass moment of inertia, it is m into distance square. Like that we can derive those quantities. But let us come to this question. Moment of inertia, areal moment of inertia, area into distance square. Area you know very well. I measure the area in SI system in meter square, and distance again meter square. So meter square into meter square will make it length to power 4. Is it okay? So moment of inertia is represented as L to power 4, correct? Now let us go to the third one, which is called work. Work done, you know very well, is nothing but force into displacement. Work done is defined as force into displacement. I apply a force on this duster and apply this force starting from this position, and I will displace it to a distance of, say, from here to here. So, what is the force I am applying? F, and the distance moved, that is actually the work done. Then you may be thinking, suppose if there is no displacement, I am applying force. Suppose you have a very big almirah in your house or in your room, and you are applying the force to push it, but you are not able to displace it even 1 mm or 0.1 mm. The work done will be 0. So, mind it well, it is very important. You may apply force, but displacement can be 0 sometimes, and then work done will be 0, correct. So, let us see the basic force into displacement. Force is defined by mass into acceleration. You remember the formula, F is equal to ma, same thing. So, F is equal to ma, it means mass into acceleration into displacement. Mass represented by m, acceleration just now we did it, Lt minus 2, and displacement is a distance, again in meters it is in L. So, let us combine this, m to power 1, m to power 1, L to power 1 and L to power 1, L square, T to power minus 2. So, work done is represented by the dimension m L square T minus 2 based on mass into acceleration into d. Is it okay? Let us come to the last one, very interesting. Last one is the strain. You know very well, any strain you want to take, aerial strain, volumetric strain and length strain. Change in length divided by length. Change in length in meters divided by again meters. So, you can see in the cursor, change in length L divided by the length L. What will it become? You know very nicely, both with cancel, and it will be a L to power 0 or a constant, dimensionless, exactly like our specific gravity, correct. So, whether it is a longitudinal strain or aerial strain or volumetric strain, which is there in the bulk modulus, you remember, the dimensions are 0. It means L to power 0, m to power 0 and t to power 0, no dimension. It is a ratio. Any ratio you take, it is going to be dimensionless. Is it okay? So, this particular problem, which is on system of units, he is trying to tell you how to derive the primary dimensions for a given variable. The variable can be acceleration, the variable can be moment of inertia, and the variable can be velocity or your work done. We can derive based on the fundamental definitions, correct. So, hopefully you understood the concept, how we have got the answers for this particular problem, correct. Let us go to the next one. This question is very straightforward. Write units of number 1 surface tension, number 2 dynamic viscosity, number 3 power, next is momentum, and the last one is pressure. Surface tension, as I described earlier also, surface tension is force per unit length, correct. It is a tension at the surface. You remember the membrane, a blade was not sinking or a bird can walk. Surface tension is force per unit length. Force is given by Newton and length is given by meter. Is it okay? Then comes the dynamic viscosity. I think I will derive it. Let us see here, tau is equal to mu into du by dy. This is a shear stress n by meter square, mu meter per second into 1 by meter. U is the velocity meter per second, y is the deflection or the gap meter. So, meter cancel, you can see mu comes out as Newton second per meter square. Sorry, I am writing here, but you can see this much only. We can derive based on the fundamental dimension. Now, let us come back to the power. The rate of doing work is measured in the SI units in watts or joules per second. Momentum, what is momentum? Momentum is mass into velocity. Let us see same thing, I will write here. momentum is mass into velocity. Mass is in kg, velocity is meter per second. Momentum. So, momentum can be defined based on the fundamental dimension mass, that is kg, into velocity meters per second. Is it okay? Now, pressure, the last one. Pressure is well defined as force upon area. Pressure is well defined as force upon area. Force is in newtons, area meter square, or it can be in Pascal, directly Newton per meter square. Is it okay? So, this particular question, which is a very straightforward and simple, it is asking you the units of, units means SI units. You did not write CGS, you did not write FPS. It is basically surface tension, number 1, that is nothing but force per unit length, you remember, Newton per meter. Dynamic viscosity, we derived from the basics, Newton second per meter square. Power, watts. Momentum, mass into velocity, that is kg meter per second. And the pressure, which is nothing but force upon area. Force is Newton and area is in meter square for the SI units, or we can say it is Pascal. So, it is a very simple question. All these 3 questions which we have described, one is the conversion of units into SI system, next one is to convert the basic variable into MLT form, and number 3 to write the units in the proper SI system. So, they are very straightforward question. We can go to the next one, correct. Now, let us start our problems based on this question on specific weight and specific gravity. But before I continue, I would like to give a mantra, you can say step 3 step mantra, how to solve a numerical problem. It can be any field, maybe strength of material, maybe mechanics, maybe anything, thermodynamics, whatever you read, fluid mechanics also. Let us go to the board. You can see here, I have mentioned very clearly how to solve a numerical problem. The question is like this: how to solve a numerical problem. You may be thinking, what sir is telling, we know how to solve. I say that first step, number 1, note down the given data, and convert the given data into SI units. We are talking about SI units, you know, kg, meter cube, Pascal, meter, all those things. It means note down the given data, whatever is given in the question paper or in your test book also, and convert the data into SI units. Example, say diameter is given in 100 mm. I think we have just now done a numerical, if you remember. Diameter is given in 100 mm of a pipe. I want to solve this numerical, but first I have to divide it by 1000 to convert it to 0.1 meter. That will be actually in SI system. Is it okay? So, like that, whatever number of variables are given in the problem statement, you note down, and one by one you convert the data into SI units. This is the step number 1. Is it okay? Let us go to the step number 2, which is very important. The step number 2, note the objective of the problem. What is the meaning of that? What is he asking in the question? What is he expecting? Whether he is asking you to find out efficiency, whether he is asking you to find out hydraulic jump, whether he is asking you to find diameter, whether he is asking you to calculate friction factor, what is the question objective? So, we say what is asked in the question. For example, I take shear stress, find out the shear stress in a pipe, find out the shear stress. It means what is the objective? It is the shear stress. So, the step number 2 is what is the objective of the problem. Note down, do not hesitate, like this only we will learn. First, convert the data into SI units, next note down what is the objective. Let us come to the third one. The step 3 is a very interesting and very important. Step 3 is the formula you need to write. For example, I have asked you shear stress here, correct. So, you need to write Newton's law of viscosity, say tau is equal to mu into du by dy. correct. I am asking you calculate the shear stress. You need to write the formula for shear stress is equal to mu, which is dynamic viscosity, into du, which is the change in velocity. We say u2 minus u1, and dy, the gap, y2 minus y1. So, you need to write that so that you can achieve the objective in 3 steps. So, hopefully my students have understood how to solve a numerical problem. First, they will note down the data which is given, they will convert into SI units. Number 2, they will identify what is the objective of the problem, then they will note down the relevant formula. Whatever relevant formula is there, you write, you substitute in SI unit, you get the answer. So, it is so simple, the 3-step mantra, correct. We will come back to our problem now. Let us start this question, which is on specific weight, which is nothing but weight per unit volume, specific gravity. Let us see what is the question statement. The density of a certain type of jet fuel is 775 kg per meter cube. Repeat, the density of a certain type of jet fuel is 775 kg per meter cube. Question is, determine its specific gravity and its specific weight. So, very clearly we will follow the same mantra. First of all, what is given? Given is density of the fuel. What is the value? 775 kg per meter cube, correct. Number 2, note down, slowly note down, no issue. Density of the fuel is given as 775 kg per meter cube. We have to assume density of water, which is the standard value, as 1000 kg per meter cube, correct. Assume the standard value of density of water, you should remember it is 1000. For air it is around 1.12, for water it is around 1000, it should be on your lips. Now, first one is determine the specific gravity. You remember I taught you the specific gravity of a liquid, or it may be petrol, or it may be any jet fuel, whatever it is the density of the liquid divided by density of water. Repeat, the specific gravity is defined as density of the liquid divided by density of water. Now, what stops you? 775 is the density of the jet, which is given in the numerical, and divide by 1000, you get value as 0.775, correct. So, definitely this is a very straight problem in which we are going to get this one. Let us come to the second part. The second part is specific weight. What is the specific weight? Specific weight, the formula is density of the fluid into 9.81. Density of the fluid, which is given as 775 in the question, substitute here and multiply by acceleration due to gravity as 9.81. So, you can see the value is 7603 Newton per meter cube. You can verify, but you can see one more thing. Question, you may be thinking, what is this? A very simple question. One is the density of the jet divided by 1000, we get specific gravity. It is as per definition, and the gamma of the jet is also simple. Take density of the fluid and into 9.81, that is gamma fuel is equal to rho fuel into G. Value is 7603 Newton per meter cube. I have divided by 1000. Can you observe that? If I am dividing this by 1000, it is becoming kilonewtons per meter cube. So, mind it well, I can give sometimes the reverse. I can give you 7.603 kilonewton per meter cube. You have to multiply by 1000 to reach Newton per meter cube. So, is it okay? So, we are able to find out the answer in only 2 steps. So, straightforward. Is it okay? Let us go to the next question. Let us take one more question. The statement is very simple. Specific gravity of oil is 0.87. In the previous case, density was directly given to you. This time he is giving you specific gravity, correct. Find the specific mass, which is nothing but density, and weight density. So, he is asking you find the specific mass per unit volume and weight density, weight per unit volume, that is weight density, okay, specific weight. Let us see how we can solve. I think this is very simple. The given value is specific gravity is equal to 0.87 is equal to density of the liquid divided by 1000. Value is 0.87, density of the liquid which we do not know, divided by density of water, because it is a ratio of the two. So, if you calculate that, if you multiply using your calculator 0.87 into 1000, it will be 870 kg per meter cube. Is it okay? So, we have obtained now density of the liquid. So, the specific mass which is called mass per unit volume. What is specific mass? Mass per unit volume. Mass is in kg, volume is meter cube. So, the answer is 870, correct. Now, after finding the specific mass of this particular oil whose specific gravity is 0.87, he is asking you to calculate weight density. He is asking you to calculate specific weight. What is specific weight? Just now we repeated in the previous problem, it is weight per unit volume. So, we say weight density 870 into 9.81. It means weight density is equal to rho into g. Rho value is 870 kg per meter cube for the oil, and acceleration due to gravity 9.81. You can see you will get 5347 something like that, correct. Let us see next question. In the next question, it is on again density, specific weight and specific gravity. A reservoir of oil, you can assume say oil bunker, has a mass of 825 kg. He has given you the mass. A reservoir of oil has a mass of 825 kg. The reservoir has a volume of 0.917. It means if I take this duster as a, you can say oil container, it has got a weight of 825 kg and this volume means pi by 4 d square into v length, whatever it is, the value is 0.917 meter cube. He has given you the volume of the container and he has given you the weight of the oil. What is the weight? Not weight, mass of the oil as 825 kg. Now, he is asking you compute the density of the liquid, specific weight and specific gravity of the oil. Question is straightforward, very simple. I told you step 1, what is given? Mass m is given in the container or reservoir as 825 kg, correct. The volume is given as 0.917 meter cube, correct. The volume also is given and mass also is given. Let us take one by one. The density of the oil, which is the first question, objective. Formula is mass per unit volume. Mass of the liquid divided by volume. I have given m by v. M is given as 825, you can see in the question, and v is given as 0.917. If you calculate, you will get 900 kg per meter cube. Is it okay? I think you can calculate, you have calculator. So, mass of the oil is 825, volume of the reservoir is 0.917 meter cube. You divide that, you immediately get density of the oil as 900 kg per meter cube. Let us see this one, specific weight. I think I have told you many times. What is specific weight? Yeah, you are right. It is weight per unit volume. Weight is equal to mg divided by volume. Same to same, density of the liquid into 9.81, what we did in the previous problem, same thing we are repeating here, because fundamental definition remains the same. So, the gamma of the oil is nothing but the density of the oil into acceleration due to gravity, which is 9.81. So, the answer is 8829, that you can verify, and the unit is Newton per per meter cube, which is the weight per unit volume. You can convert this also in kilonewton per meter cube. How? By dividing by 1000. So, if you divide by 1000, you get 8.829 kilonewton per meter cube. Is it okay? Now, let us come to the last part of the question. He is asking you specific gravity of the oil. As I told you, specific gravity is a number. Specific gravity is the ratio of the density of the oil divided by density of water. Density of the oil on the top divided by density of the water in the bottom. Now, you can see here, normally I take 1000, but I have taken slightly different value, slow 998. You may be thinking why. See, I told you in the previous class, if you heat the water, its density will slightly come down, correct? If it is 1000, it will slightly come down to 998. Anyway, I have purposefully taken it 900 divided by 998, around 0.9 you will get. So, this is the way this question is solved. So, you need to understand the basic definitions which we have taken in the class 1 and class 2 to describe the various characteristics in which the numerical will be based on, they will be giving the data like mass is given as 825, volume is given as 0.917, they will ask you to calculate density. You should say what is there, it is mass per unit volume, substitute the value, get the answer. Gamma of the oil, rho into G, you know the rho is 900, G is 9.81, finished. And then we have a specific gravity which is the ratio of the two densities, density of oil divided by density of water. So, 900 by 1000 also I can take, I am not disputing you, but just for a change I have taken 998 just to show you that if I heat the water, density will slightly come down. Is it okay? Now, let us go to the next problem. Next problem is also very interesting on density on specific gravity. A tank contains 500 kg of liquid whose specific gravity is 2. Oh, 2, it is 2 means double heavier than water, correct. A tank contains 500 kg of liquid whose specific gravity is 2. Determine the volume of the liquid in the tank. Given density of water can be taken as 1000 kg per meter cube, right. What is the question? Tank contains 500 kg of liquid. He has given you the mass. He has given you the whose specific gravity is 2. Determine the volume of the liquid in the tank and density of water he is giving. Mind it well, we follow the same method. First step which I told you on the blackboard, also given what is given in the question, mass of the liquid as 500 kg, nice. Specific gravity as 2. Density of water as 1000 kg per meter cube, right. Once you note down, we will start. What is the specific gravity of the liquid? I think my students, they know it is the density of the liquid divided by density of water. I repeat, specific gravity of the liquid is the ratio of the density of the liquid divided by density of water. Okay. Now, in this case you can see the value is given as 2. I will equate it and you can see 1000 I will multiply, I will density of the liquid as 2000. As I told you earlier also that density of water is 1000, specific gravity is 2 means it is double, correct. So, understood that density of the liquid is 2000 kg per meter cube. Once you calculate the density of the liquid, he is asking you mass of the liquid, he is asking you the mass, determine the volume. Now, we are going to apply the formula density of the liquid is equal to mass per unit volume. Mass is given as 500 kg, substitute. Volume of the liquid I do not know, means in the question I know the density of the liquid as 2000, I will substitute here. So, you can see here 2000 he is here, 500 is there. When you calculate volume of the liquid, it will, the answer will come as 0.25. Is it okay? So, this question is a very interesting question, very nice. of competitive level, of VTU level, we can say in this mass of the liquid is given as 500 kg, specific gravity is given 2, density of water is given 1000. So, we first taken the specific gravity of the liquid, the ratio of density of the liquid to density of water. Water is 1000, specific gravity is 2, 1000 into 2, 2000. I come back to the basic formula of the density of the liquid, which is mass per unit volume. Mass is given as 500 kg, volume of the liquid I do not know, density of the liquid is 2000, and I solve it, we get the answer. The volume of the liquid in the tank, this tank is 0.25 meter cube. So, once you know the fundamental definitions of these characteristics of fluid like specific gravity, specific weight, density of the liquid, specific volume, which is 1 by rho, we can solve the numerical without any problem, correct? Is it okay? Now, let us go to the next question. Again, I would like to calculate the specific weight, density, specific volume and specific gravity of 1 liter of petrol. He is given it weighs 6.5 Newton. 1 liter of petrol, he is giving you the weight, he is giving you the volume, and he is asking you to calculate specific weight of petrol, density of petrol, specific volume of petrol. It is a very interesting question again of the university level. First we see what is given. I told you very clearly the step number 1. The step number 1 says that given volume V is 1 liter, we will convert this to meter cube by dividing 1000, correct. So, 1 by 1000 0.001 meter cube. So, I know the volume. Weight of petrol, which is given as 6.5 in the statement, you can see here petrol weighing is 6.5 Newton. So, we have converted this one and then we are going to the formula. The specific weight of petrol is given by weight per unit volume, fantastic, because it is the basic definition. What is the specific weight? Do not confuse with density, that is the mass per unit volume. Specific weight is the weight per unit volume. He is asking you what is the weight of petrol. The answer, petrol weighs 6.5, substitute. What is the volume in SI system, not in liters. My dear friends, take care, they are all very small thing, but they are equally important. He is asking you volume in SI system, not in liters. So, you can see here we have converted 1 liter as 0.001. So, substitute here. Once you substitute there, you can calculate using your calculator 6.5 divided by 0.001 as 6500 Newton per meter cube. It means you got the first one. It means you got the specific weight of the petrol. My dear friends, whenever you go to petrol bunk, in some of the bunks they will mention the density or specific weight exactly like this only. You can check the number is correct. Okay. Now, let us go back to the numerical. He is saying that the weight is equal to m into g. What is the weight of petrol? As I mentioned, 6.5 Newton. M mass I do not know. G value is a universal value 9.81 meter per second square. You get the mass of the petrol as 6.5 divided by 9.81. Is it okay? That is actually the mass of the petrol, 0.6626 kg. How we got? By the formula W is equal to m into g. W is 6.5, g is 9.81. So, we can get the mass of the petrol. You may be thinking why I am talking about the mass. You remember, my dear friends, he is going to ask you density. What is density? What is density of petrol? It will be mass per unit volume. What is mass? 0.6626. And what is the volume? Not 1 liter, it is 0.001. We have to substitute here. You can see the density of petrol is around 662.6 kg per meter cube. You can also calculate by using your calculator. It is a very practical problem, a good problem. Now, one more thing is asking you, specific volume. I think I have told you that specific volume is nothing but the reciprocal of density. Specific volume is defined as 1 by density of petrol. So, specific volume I want to calculate 1 divided by 662.6, I will substitute here and I will get a value. Please calculate exactly 0.00151 meter cube per kg. So, this is the way this question has been solved. Very good question, very interesting question, in which he has given you the weight of the petrol for 1 liter. He is asking you first the specific weight, that is weight per unit volume, that is done. Then we calculate mass using the formula W is equal to m into g, that is done. Then mass is 6.5 and 9.81. Then density of petrol by the fundamental formula mass per unit volume, we got the value as 662. And lastly he is asking you specific volume, which we have calculated based on the basic definition. It is a reciprocal of density of the liquid or density of the petrol. So, 1 by density of petrol, I get this value 0.00151 meter cube per kg. So, is it okay? So far we have done problems, very fundamental problems, very simple problems, right? Oh, I think specific gravity is also there, sorry. Specific gravity of the petrol, you can see density of the petrol divided by density of water, 662.6 divided by 1000. Okay, very sorry. Specific gravity of the petrol is calculated based on the ratio of density of petrol divided by density of standard liquid, which is water. So, 1000 I will take here, 662.6 will come from here, it will come here, and the value is 0.6626, a dimensionless number, and you can see petrol is lighter than water, correct? Petrol is lighter than water. Now, we will go to a different domain. So far the problems which I have discussed here is based on the system of units, based on the basic properties of the fluid, which is nothing but specific weight, which is nothing but density, is nothing but specific volume and specific gravity. We solved around 8 problems. In that problems we have learned how the basic definitions can be extracted to get the correct answer, provided we substitute in SI units. We also learned that MLT system, how it is important, the primary system for the variable like acceleration, like velocity, like surface tension, like work done, all those based on the fundamental definition. Let us do this problem and close today's class. On viscosity, I take a plate of 0.025 mm distant from the fixed plate, moves at a 50 centimeter and requires a force of 1.471 Newton to maintain this speed. Determine the fluid viscosity between the plates. We are assuming here, if area is of the plate is not given as 1 meter square. This question is like this, I will just show you. It is a plate, I am moving with a velocity 50 centimeter per second, I will move like this. Okay, 50 centimeter per second, I need a force of 1.471 this side. This gap is 0.025 mm. Can you imagine? Even this itself is 25 mm. 0.025, we assume this area is 1 by 1, which is a area of the plate as 1 meter square. He is asking you what is the viscosity between the plate. He is asking you what is the resistance offered by the plate. Let us go back to the question. Assuming the area as 1, given dy as 0.025 mm, change in velocity on the top to the bottom 50 centimeters per second, force given as 1.471. So, my dear friends, as I told you in the step 1, dy need to be converted to meter by 0.025 divided by 1000, 50 centimeter per second need to be divided by 100, f is already in Newton. Let us see. First unit conversion I have shown very nicely here. Step 2, dy is 0.025, so we have divided, we got the answer as 0.4025 meter, du as 50 centimeters per second, 50 by 100, 0.5, Let us see the formula. As I told you, what is our objective? Our objective is to get mu. What is mu? It is a dynamic viscosity. So, if I substitute shear stress is equal to mu into du by dy, mu I need to know, I know du is 0.5, dy I know, I substitute here and I get shear force as tau into A. Assuming that force is given as 1.471, I put shear force as 1.471, shear stress this value mu into 0.5 divided by 0.000025, that value is substituted, you get immediately the dynamic viscosity in Newton meter per second square. So, this question has given you just an beginning how we have to solve the problem on viscosity, in which we need to convert this mm to meter, is done here, du to meter per second divided by 100, and this formula which is the objective, tau is equal to mu into du by dy, that mu is the dynamic viscosity, 0.5 divided by dy value which we already converted here, and we got the shear force as shear stress into area, area is assumed as 1 meter square, and we got the dynamic viscosity. So, with this I stop today's lecture. My dear friends, please come with your calculator, be ready with the basic definitions. I will always revise, and today we have learned the how to solve the problem on the SI units, on the MLT system, on the specific weight, density, specific volume, specific gravity, and a sample problem on the viscosity. Along with that, we also learned how to go about the solving a problem. We have 3 units. First, note down the given data. Number 2, what is the objective, and number 3, write the relevant formula and substitute them in the SI units only. Then only you will get perfect answer, and that will be the way we are going to solve the numericals. Thank you once again. Sorry.